Hello there, welcome to new video in software engineering. Let me make it my screen big. In today's class or video, we are going to see something about design model, which is a part of Unit 3, Chapter 1, Design Engineering. We are going to see design models. The design model diagram is shown, the figure is been shown. On a horizontal line, we see process dimension. On a vertical line, we see abstract dimension. And we have seen analyze model, and this is design model in 3.2 video. So as we move on, in the analyze model, the abstract is very high, whereas in design model, the abstract is very low, because we will be going to see all the detail in design model, whereas in analyze model we are going to see the abstract model. As by see, abstract is there. Here it is very high, here it is very low, and there are 4 parts: architectural element, interface element, component level, development level model. So in the development level model, if you go to analyze model, we see high level of abstraction, whereas if you see here low level of abstraction. The same elements are the components are there, but we will see high element of high process, high element of the abstract, whereas here low level of abstraction. Whereas here if you see component level of element and analyze model, we see a high level of abstract, here we see low level of abstract. It is already mentioned here in the diagram. The same way comes with interface and this one. And how do you get a high level of this one? Because we have an abstract, we go for iterative refining part. Iterative refining part means doing that same thing again and again, refining it until you get a very good model. So once you go deep, you will go, all the details are available here. So the point is very clear. In the design model, if I draw a graph or if I draw something like that, on a horizontal line I go for process dimension, on a vertical line I go for abstract dimension, and on the analyze model it's very high, and design model it's very so. Once I go down, design model, analyze model, if you see architecture, its abstract is very high. When you go down in architecture element of design model, abstract is very high. If you go down the same way, if you go for interface element, the abstract in analyze model is very high, and whereas here it's very low. This is what the diagram says it. Now if you see it, the same process, the horizontal line is nothing but your process dimension, and your vertical line is something like your abstract dimension, which is already mentioned here, correct? And the next part is that the diagram is refined, re-refined and elaborate as part of a design. Re-refine, as you move down you re-refine it, as you move down you re-refine it to do it. As you re-refine, you get all the details available. Implementation specific, we have got architectural, structural design, interface, component design outside the world, this was, and component that reside within the architecture. This is what architectural element, interface element, component level, and develop level element, which are available. Now if I go this one, this is an analyze model, this is a design model. The analyze model, higher abstraction level is available, that define this one. If you go for architectural one, architecture, we have got class diagram, analyze in package, CRC model, collaboration, data flow diagram, control flow diagram, processing, narration. And the same part here, if you go class, design class, realization, substep, subsystem terms, collaboration diagram, all this comes in design model. Detailed observation will be given here. So if you see here the diagram, class diagram represent the static, means whatever there it is available. Analyze package, group related elements are available. Class responsible collaboration, CRC model, which is available at analyze model, where abstraction is very high. Collaboration diagram, data flow diagram, all this. In design model, as we move from analyze model to design model, we have high to low abstraction. What do you mean by low abstraction? We are going to see more detail detail in this one, involve more detailed elements in this one. So provide detailed description of a class implementation, whereas here only static structure, subsystem, group classes, larger functionalities, what are they, collaboration app, continue to show interaction between the systems and everything. This is what it is been shown. As I mentioned before, when you go to analyze model, it's high. When I go to build, it's low. Correct? Now let's move on to this one. The process dimension flow. The process dimension flow. Again, I move to this diagram. This is where it is, and it's got architectural element, interface element, component element, and deployed level model. So here also the process follow from higher abstraction analyze model to lower abstraction model, redefining each element, adding more development, adding more detail. So as we move from higher to lower, defining more detail, more details are there, plus adding elements are there. Each category, character, architecture, interface, component, and deploy involves specific set of diagram model that provide. This diagram provides structural approach for transaction from high level to low level. This diagram applies from process which move from higher level to low level. Now, design model elements are not always in a sequence. Now, if you see this one, you have mentioned that there are architectural water, interface, architectural element, interface, component. They are not going to do in a sequence process. As we see it, the model is not always developed in a sequence. Not always developed in a sequence. Primary, first architectural set, a designer set, the following the interface design, component level, whichever ways which come are run in parallel. One after the other or in parallel. The design model also follow the layered element. That is data class diagram, architectural design, interface design, component level. This will follow it. Correct? The fifth element follow the deployment level of design. We are going to see all those things in details. Now, data class diagram, as I say, this one, which run here. Data class diagram, create a model object that represent high level abstract. The goal is to define the data structure, means what language you are going, what relationships are there, what are the different entities you are going to do. Then architecture despite overall layout. Once you define which language you are going, overall layout of the software, interface, how the information flows from higher to lower or from one system to other. Tells you how information flows into and out of the system, how the communication goes up. This is part which include user interface, external interface, internal user interface, user which is want to get into the system, and external interface is something like that. External user want to get it, and internal interface. Component level design describe the internal design, show the software component by the way the structures are being developed. Deployed level design element indicate how system functionalities and subsystems are related to allocate within the physical element. It focus on physical distribution of software component. All those things comes here. So data and class will give you abstract, architecture will give you layout, interface, how they are communicated. Then we have got user, external interface, another component level description, and how the functionalities are being done. Now design model elements. What are the elements in design model? This is our design model, correct? This is our design model. What are the elements of this one? R4 module, and we are going to see this one, correct? What is this one? Data model, data structures. Means what the software uses, how the data is stored, how the data within the system is used, that is used in the how data is stored and organized. What are the software is going to use, which software is going to use, and what are the properties of the system, how the data structure is stored, how architecture entity are related to each other, how data is stored, how we are going to retrieve that one, correct? So first one, data structure, which software and what you are going to do, how with architecture you are going to do, how we are going to retrieve. And then architectural domain specific. If you go for Make My Trip, it's only for holidays, other things. If you for government website, you go for something. If you go for Osmania University result website, you will only get result. That is domain specific. Analyzing class relations. What are the relationship? What are the collaboration? What are the behavior? Transformation. When? What are the blueprint? Everything has to be specified. Pattern style means what are the reusable, robust, maintainable are applied to this. Model view control. Model view control are been. What are the interface? As I told you, user interface, user friendly, meeting requirement. External interface, how it's required to do with the external information. How they are connected with the internet. Component level. Deployment level is something like the described software functionality subsystem within the environment. It meets to the requirement. So design model is something like that, where you go up which software you are using, what are the database you are using, it is a domain specific, what are the analyzing you are going, are you doing with pattern specification, interface, that is user friendly, meet requirement, external interface, all these are been specified in this one. Now let's move on to other part. Now this is an example which is given to you. We have got a control panel, a wireless PDA, mobile phones and interface keys. These are live. What is this? Interface represented control panel, LED display, LED indicator, key type characters, speaker, wireless interface. Then these are its function. These are control panel. These are the attributes. These are the keys. Correct? This is a class. Read keys, decode and everything. And this is PDA, how it is connected. We are going to see this one. Correct? Attribute, control panel. What is control panel here? This is the control panel. Okay. What are its attributes? LED display, screen display, LED indicator indicating keypad characters, speakers, and what are the methods? What are the methods? Read keystroke, read the input from the keyboard, decode that one, display that one, light the LEDs on this one. Send a control message. If you see it, it's going to send a control message. It is going to see a control message here as well as here. Then keypad interface. Where is keypad? Methods. Keypad interface. We have got keypad interface. Methods. Read keystroke. We have already did the keypad method. This is read keypad stroke and read the keypad decode this one. Wireless PDA, personal digital assistance. What I am going to do with the help of mobile phone. This is an example of control panel. Design model, how it is going to say it. Then we have got component. Based on this one, we are going to do component model. What is the component? This is sensor management and this is a sensor. What is the sensor here? Which is sensor here? It is a sensor here. Where it does? Let me check it out. Yeah, the same way. Sensor. Where it is sensor here? LED, keypad, wireless interface, decode, sending control, wireless keyboard, and all this one keypad, and this one will come up here. Now next part is this one. Control panel. There is a security for it. Home server, home owner access, and this one your external security, surveillance, and everything. This is deployed elements which are given here, and dotted lines are nothing but they are connected. Personal computers which are all have external access, security, surveillance, management. It is connected to the security and it is also connected to the homeowner. This is nothing but your deployed model. And component of the diagram. Component of the diagram. This is security. Component is security. Where it is? Yes. Security. Here it is given as security. It is description. The control panel like represent a centralized device of same home system handling all this. CPI server. Where is CPI server? It's here. Homeowner. CPI server and it is a homeowner. What it says? Home access. Description. Component access to the system. Homeowners and others are given to it. Personal computer. External access. Security. Surveillance. Home management. Communication. Dash line. This dash line, the diagram indicates physical connection between the two different hardware components. Key point, how you are going to deploy this one. This is what we are going to see how deployed model is, what is component model, what are interface, how they are going to build. This is an design model element and this is the diagram for it. I hope you got it today. I'll stop it here. We'll continue the next part in my next video. Thank you very much.